So a 2-gram sample of a compound gave 4.8 grams of carbon dioxide and 2.03 grams of water upon combustion in oxygen. Finds its empirical formula. All right. So now this sample, we don't know its composition. We don't know how the atoms reacted in this sample. So we've been given this sample which we don't know, but we've been told after combustion, that means after reacting with oxygen, it produced carbon dioxide and water. Now this compound contains only carbon, hydrogen and oxygen. So we don't know in the ratio in which carbon, hydrogen and oxygen are in this compound. But all we know that 2 grams of this compound after combustion produced 4.86 grams of carbon dioxide and 2.03 grams of water. Okay. Now I want to determine the empirical formula. So the first thing is, let's work out carbon dioxide. So the first thing, let's find the molar masses of these substances, the carbon dioxide. So let's talk of carbon dioxide. So I've got 2 times 15.9994, and then carbon is 1 times, that is 12.0107. So what mass is it going to give us? So that is 2 times 15.9994 plus 12.0107. So that is giving me 44.0095. Let's also work with water. So water has got 1 oxygen with 15.9994, and then 2 hydrogens. Now 2 times 1, the molar mass of hydrogen is 1.008. Multiply that by 2. That is going to give us 2.016, and then add these 2. So plus 15.9994. So that is giving us, okay, that is giving us a value of about 18.0154. 18.0154. Okay. Now I want to find how much of carbon is in carbon dioxide. Alright. So I need to first determine the moles of carbon dioxide. So number of moles of carbon dioxide is the mass over molar mass. So the mass we've been given is 4.86. The molar mass of carbon dioxide we found 44.0095. So that will give us 4.86 divided by 44.0095. So that is giving us 0.11043 moles. Alright. Now, as we can see, in 1 mole of carbon dioxide, 1 carbon dioxide only contains 1 carbon. So 1 mole of carbon dioxide contains 1 carbon. Therefore, number of moles of carbon dioxide is equal to number of moles of carbon, which is equal to 0.11043 moles. Alright, so that will be our answer there. The same thing, we need to determine the moles of water, and hence determine the moles of what? Hydrogen. Okay, let me just clean up the upper space. Alright. So what are the number of moles of water? So number of moles of water is also mass over molar mass. So the mass of water we've been given 2.03 over the molar mass we have found 18.0154. So that will give us 2.03 divided by 18.0, okay, 18.0154. That is giving 0.11268 moles. Now, one water molecule contains 2 moles of hydrogen. As we can see, in 1 water we have got 2 hydrogens. Now these moles we found are for water. So 0.11268 moles are for water. How many moles of oxygen of hydrogen will be there? So we cross multiply. That will be 1 times x, that will be x, and then we just multiply that one by 2. That is giving us 0.22536 moles of hydrogen. So we have found the moles of hydrogen and the moles of carbon. Okay, moles of hydrogen and moles of carbon are found. So the other thing we just need to find is the moles of oxygen in this compound. Now let's first convert this to mass. So mass of carbon, how do we find mass? We know that number of moles is mass over molar mass. So we cross multiply. Mass is going to be number of moles times molar mass. So the mass is going to be n times molar mass. So the number of moles of carbon we've been given as 0.11043, then times the molar mass, that is the molar mass for carbon is 12.0107. So same, let's find the mass of hydrogen. Mass is number of moles times molar mass. So this one here is for carbon, this one is for oxygen. So the number of moles of carbon we have found 0.22536 times the mass of hydrogen. Sorry, we are talking of hydrogen here. That is 1.008. Okay. So what are we going to find? So we're going to multiply our 0.22536 by 1.008, and our answer is going to give us 0.227165 grams. What of here? Are we going to find? That is 0.11043 multiplied by 12.0107 is giving me 1.326 grams. Now what we need to understand is, if this is the mass of carbon which was present in carbon dioxide, this is the mass of this was hydrogen. Yeah, this was hydrogen. This is the amount of hydrogen which was present in water. Mass is neither destroyed nor made, but it can only be from one part of the equation to another. So in other words, in a chemical reaction, there is no new mass that is formed, and mass is not destroyed. The same mass that you had at the beginning is the same mass that you have at the end. If this is the mass of carbon which was present in carbon dioxide, it means this is the same amount of carbon which was present in the sample. Same with this amount of hydrogen. This is the same amount which was also present in the sample. Now what amount of let's say oxygen was present in the sample? So the amount of oxygen, we want to find now the mass of oxygen in the sample. What is it? Okay. So the mass of oxygen in the sample will simply be the total, that is 2. We remove the mass of carbon and also remove the mass of our hydrogen. What remains is our mass of oxygen, because this compound was only made up of 2 substances. So 2 minus 1.326, again minus 0.227165. That is giving us 0.44649. So this is the mass of oxygen. So what are the moles of oxygen present in this amount of mass? So remember, number of moles is mass over molar mass. So the mass is 0.44649. The number of the molar mass is 15.9994. So we divide by 15.9994. So that is giving us 0.0279 moles of oxygen. So we already have now the moles of hydrogen, the moles of carbon, the moles of oxygen. We can now determine the empirical formula in this case now. Okay. So say we have got element, we have got carbon, hydrogen and oxygen. What are their moles? Our carbon, the moles is 0.11043. Our hydrogen, the moles 0.22536. Our oxygen, the moles is 0.0279. Okay, so from all these moles, which one is the smallest? Which one is the smallest? All right, so this is 0.1, so 0.2, this is 0.0, so oxygen is the smallest, so we are going to divide by 0.027 to determine the mole ratio. Okay, so this one divided by itself will give us 1, and then 0.22336 divided by 0.0027 is giving us about 8. And then for carbon, that is 0.11043 divided by 0.0279, that is giving us about 3.9, which is 4. So our empirical formula therefore is carbon 4, hydrogen 8, and oxygen 1. That will be it. Let's look at the last question. 15% by mass of aqueous solution of silver nitrate has a density of 1.141 grams per milliliter. What is the molarity of this solution? So we have been given sodium nitrate. Let's determine the molecular mass. We've got 3 oxygens times 15.9994. We have got 1 nitrogen. So nitrogen multiplied by 14.00674. Then we've got silver is only 1. That is multiplied by 107.8682. Let's find the total here. So that is 3 by 15.9994 plus 14.00674 plus 107.8682. So that is our 8682. So that is giving us 169.8314 grams in 1 mole. Now I've been told only 15% by mass of this as a density of that. So what is 15% of that value? So 15% is 15 out of 100 times this mass, 169.87314. That is going to give us, so times 15 divided by 100. So that is giving me, that is 25.480971 grams per mole. Remember, this is molar mass, this is grams per mole. Okay, that is what we have. So this is the one which has got a density of 1.14. Okay, that is 1.14. I don't know if that is the one I can see clearly. Let me just use 1.141. We've been told grams per milliliter. Now I want to convert into molarity. Now we know that molarity, simply the moles of solute over liters of solvent. So our molarity, the unit is in moles over liter. So I want to make sure that this unit is converted, this density is converted to mole per liter. So that is 1.141 gram over milliliter. Okay, so this one we are found in grams per mole. So what we are going to do is we are going to multiply. The first thing is, let's convert this liter, milliliter to liter. Okay, by multiplying by, so we have got milliliter down, let's put a milliliter on top, and then liter down. Now in 1 liter we've got 1,000 milliliters, so that and that goes. So our answer is in grams per what? Per liter. Okay, but our answer, we want our answer to be in what? In mole per liter, not in grams per liter. So we need to convert this gram into mole. So how do we do that? We are going to multiply So remember, this value you found is in gram per mole. Okay, so if we reciprocate this one, it will be in mole per gram. So if this one is 25, let me just write 25. Of course it's 25.48 grams per what? Per mole. So if we take the mole on top and the gram down, it becomes 1 over 25 mole per what? Gram. So if we change them like that, I hope we've understood. Gram has just gone on top, the mole has come down. So we've changed them. Mole on top, gram down, and so even the 25 is going to change. So that will be 1 mole on top over 25.480971 grams. So this gram is going to cancel with that gram. So our answer therefore will be in mole per liter, and that is what we call as our molarity. So all we are saying is 1.141 times 10 to the power 3 and then divided by 25.480971. So our answer therefore is in 44.77851 molar, which is mole per liter. Okay, this one had 4 significant figures, so let's write our answer to 4 significant figures. That is 44.78 molar. Okay, that is all for this video. Thank you so much for watching. Have a good day.